We are talking about using the ohm meter to measure the resistance of a resistor. Now basically you can separately using a voltmeter and an ammeter to measure the voltage and currents. Then this Rx can be found by using V over I, right? Using the Ohm's law. Or you can using the meter using this approach that in the ohm meters you can supply a known voltage E, okay, and you connect your unknown resistance to the network so that through this network you can set up the KVL equation where E equal to Im times Rm plus R plus Rx. Okay, now you find that this Rm, R, and Rx are series connection. Therefore, when it is multiplying by Im, then you can know E, right? Now, in this network, only Rx is unknown because E is supplying by you. Im can be read by using the meter. Rm, R should be known. Therefore, you can solve your equation that using this equation, Rx equal to G over Im minus R plus Rm. Okay? So you can get the value of Rx. Okay? Now basically, we say that in here, the internal resistance are chosen such that the external resistance is 0, so that the meter is at full deflection. So that now, if you do not connect any resistance here, but you connect a short circuit, okay? This short circuit, you know that R equal to 0. So the meter will give you a maximum current. In other words, we say that the meter will have a full deflection when you connect a short circuit at the output terminal. Okay? Now by using this approach, it can give you another formula that now in this equation, if Rx equal to 0, you have E over Ifs minus R plus Rm. Okay? So your Ifs will equal to E over R plus Rm, right? And you can make use of this Ifs to substitute the value of E here. So you have another formula to represent Rx. After you make the substitution, you can get Rx will become Ifs over Im minus R minus 1 times R plus Rm, because you can substitute E equal to Ifs times R plus Rm. Okay? You just make the substitution here. Okay? And then you can find another equation to calculate Rx. Okay? Now, as a consequence, to measurement the current is the readout of the meter will be in inverse of the resistance. Now, the meaning of this sentence is that, remember, when you have R equal to 0, you have a full deflection of the meter. That means, if your meter is full, it deflects from left to right. It means when the needle deflecting to the most right hand side, it should be R equal to 0, right? Therefore, for the other resistance, it means it will increase the resistance from right to left. It has an inverse deflection of the needle to indicate the resistance you are going to measure. Okay? Therefore, the sentence told you that you have an inverse deflection. Okay? Now, but luckily, in our laboratory, we don't use the analog meter. Okay? Now, we provide you using the digital meter. That it is easier to use. Analog meter 咧，其實係古董嚟嘅，其實你都未必有機會用啊。咁你而家仲可以，我相信我鴨寮街你可能買到嘅20蚊，你就有個 analog meter 啦，好平20蚊。 不過我哋個 lab 咧就比較先進啲，我哋用 digital meter 咁就唔使睇嗰啲針啦，係嘛因為有時睇啲針咧都有時會睇錯噶嘛，係嘛 ？OK。Now we move to another topic. Now this topic, if you remember, it is very important to us because it is the first powerful technique that we can use to solve our problem. It is so-called the nodal analysis. Okay. Now by using the nodal analysis, I can say you can solve any of the electric circuits. 全部嘅 electric circuit 你都係解決啦using nodal analysis. Okay. Now basically, now remember the last example we told you. Now for any component, we are going to find the voltage across the component. This is so-called the branch voltage. Okay. Now, but we told you that to find the branch voltage is really difficult because if you have a increased number of branches in your circuit, that means you have more and more unknowns, right? In the example we just showed to you. Now, therefore, instead of finding the branch voltage, we are going to find the loop voltage, or the voltage at the loop with reference to some other loops. Okay? Therefore, by finding the loop voltage, instead we can find the number of simultaneous equations can be reduced. This is our approach. Now, the rule is that in your circuit, remember I asked you to count the number of loops in your circuit. If you can find the number of loops is equal to n, then the number of simultaneous equations you are going to set up is n minus 1. Okay? Okay, now this is our rule. Now therefore the technique is that we have 3 steps. Firstly, in your circuit, you needed to identify the reference loop. And this reference loop is represented by 0 volt. The other loops you will assign a voltage V1 up to V, it should be Vn minus 1, okay? And they are the loop voltage with reference to the reference loop. Okay? Now, after you do that, for each loop or non-reference loop, you apply the KCL to write down the KCL equation and then the Ohm's law that replace each of the current in terms of the loop voltage. Okay? And at the end, you will set up n minus 1 simultaneous equation. And after you solve this n minus 1 simultaneous equation, you get the loop voltage. And then you can find the other parameters. Okay? And we just told you the reference, it is the reference loop, therefore it has the voltage equal to 0, okay, for the reference loop. Okay? Now, by reading the sentence here, you may not understand what we are doing here. Therefore, I try to explain the nodal analysis using the example that we provide to you here. Now, in this circuit, you may find that now you count the number of loops inside the circuit. Okay? You have 1, 2, 3, right? So we can say n equal to 3. And according to the method, how many equations you are going to set up? 2, right? You are going to set up 2 equations. Okay? And now you are going to choose a reference loop. Okay? Now normally, we will choose the loop that we show a ground symbol here. Okay? Now this is a ground symbol. Now basically, it does not mean the Earth. Okay? You may learn from other subjects that it represents Earth. That you connect a wire to the ground to discharge the current. Now this is not. Now this ground symbol represents the reference only. It represents 0. Okay? It does not mean it is an Earth. Okay? Now for the ground, we see that this is 0 volt, and the other 2 voltage, you will give the voltage to each for each of the loop. This is V1 and this is V2. And they become the unknowns of this problem. Okay? And now, for every resistance in your circuit, you will assign a current. Okay? So, you will say this is I1, this is I2, this is I3. Okay? You will assign a current for each resistance. Okay? And immediately you may ask me, oh, how can we assign the current direction? Now basically it is up to you. Remember, starting from last week, we told you that the current direction is assigned by yourself. Okay? If you get a negative current, don't worry. It means that your assigned direction is you get a wrong direction, and if you reverse the direction, you will get the positive current, right? 嗱，記唔記得上一次我提過大家咧，就電流咧由上一星期開始咧，你就唔使理佢點樣流嘅，因為之後我幫其他同學討論咧，同阿 Sir 啲電流我咁樣流喎，覺得嚇，即係你以往學 physics 係咁樣學，你要知道係點樣流，但係我哋個做法唔會理會佢點樣流，係你自己定。 係咪啊？你只要計完條數，覺得佢見到佢係負數嘅，咪知道你當初個定義調轉咗㗎嘛？係嘛？冇所謂㗎。OK。Now therefore you can define your current direction by yourself. Now if you have no idea, you can follow my idea that when the component is vertically connected, I assign a current from top to down, top to bottom. Okay. So I1 and I3 flowing from top loop to bottom loop. If it is a horizontal component, just like R2, I will assign a current from left to right. OK， 即係如果你冇乜 idea 啦，你咪跟我個方法咯如果係打直 component 嘅咧，就上而下；打橫嗰啲咧就左至右。OK， 咁當然你唔中意可以調轉嘅，冇關係。OK。Now after you do that, you apply the KCL to each non-reference load. Okay, so let me using IA, IB, and IC because it should be much clearer. Now for KCL at loop 1, okay, I1 is entered, I2, IA, IB are leaving. So you have I1 minus I2 minus IA minus IB equal to 0, right? Another loop, the KCL, you will find I2, IB are entered, IC is leaving. So you have I2 plus IB minus IC equal to 0. Okay? Now this is only the KCL. And now you are going to replace the KCL by Ohm's law for each IA, IB, and IC. So now you can see IA. Now you're using the current is flowing from V1 to 0 volt. Therefore, now this V1 originally it should be equal to let me using VA here. Okay, it should be here, right? VA minus 0, right? Therefore, IA equal to V1 over R1 or equal to VA minus 0 over R1. So, the first equation becomes I1 minus I2 minus VA minus 0 over R1. And similarly for IB, you have VA, VB. Your voltage originally should be if this is VR2, your VR2 should become VA minus VB. Okay, this is the KVL. You're using the higher potential voltage minus the lower potential voltage. Okay, so this VR2 IB equal to VR2 over R2. And you can substitute VR2 by VA minus VB. and you have VA minus VB over R2 equal to 0. Okay? Now you do the similar thing for the second equation, you get I2 plus VA minus VB over R2. And IC, you have VB over R3 here. Okay? Now you get two equations here. And you can solve these two equations because you have the unknowns, VA and VB only. Okay? Now you see the point here that the idea is that instead of finding each of the branch voltage, you can find the loop voltage instead. You are going to find VA and VB with reference to the ground loop. And after you find VA and VB, you can find the other parameters. Okay, easily. Now this is the major idea for the nodal analysis. Okay? Now you can read the sentence that we provide to you. They are more or less the same. You can see we select the reference loop. The remaining two loops, we assign the voltage and apply the KCL. Okay, and then we apply the Ohm's law. Okay, and we replace each of the Ohm's law here to set up two equations. And at the end, we solve these two equations to get the value of V1 and V2. Okay? So I may say that you can follow the step that I just told you and you can solve any circuit. Okay? It is very powerful. Okay? Now I think we need to stop at here. Okay? Now do you have any questions?